Here we are talking about triangle ABC, and we're given three measurements here, and it asks us to determine the missing measurements of all possible triangles. So we first have to figure out how many are there, right? There could be 0, where this doesn't work. There could be 1, there could be 2. So we got to figure out how many triangles, and then we'll find the missing pieces, because there's 3 angles and 3 sides. I know 1 angle and 2 sides. So to start, I'm going to draw kind of like a general sketch of what this might look like here. So we got our angle here of 33. I always like to put the angle that I'm given in the bottom left here. And the opposite side, because I have big B here, that means the opposite side, little b, is 10. And I'll put the adjacent side here, A, as 15, which means that this angle is A, this is angle C, and this is side C. So there's kind of my rough sketch. What I need to do first is determine how many triangles there are, and to do that, I need to find the height of my triangle here. So to find the height, I'm kind of creating a right triangle here where I have the hypotenuse of 15, angle of 33, and then I'm looking for the height. So I can use sine of 33, or SOHCAHTOA equals the opposite over the hypotenuse. Multiply 15 by both sides. So 15 times sine of 33 is equal to the height. When I plug that into a calculator, I get about, what was that, 8.17? And now when I am looking at this to determine how many triangles there are, all I need to do is take the opposite side of the angle that I'm given, which is 10. And if it's greater than the height, that means we have a triangle. If it's less than the adjacent side that we're given, that means we have 2 triangles. And so in this case here, that is true. Both of those things are true, meaning I get 2 different triangles. And so the 2 possible triangles that I'm dealing with, I either get a big, large triangle or a kind of a smaller, skinny triangle. So try and draw this as much to scale as possible, but I'm no artist, so got to bear with me here. 33, 15, and 10. And then my other triangle here will be a little bit skinnier, so still 15, still 33, but instead again, what you should notice here is that this side length that's 10, this B, it's either on one side of the height originally or the other. So when you look at this, right, our height is here or our height is here. So it's kind of swinging back and forth. So in this case here, I got my 2 triangles, or my 2 possible triangles. Now I just need to go ahead and solve for the missing pieces. So I'll start with my bigger triangle here. I'm going to start by solving for this angle here using the law of sines. So sine of A over 15 equals sine of 33 over 10. Multiply both sides by 15. Take the inverse sine of both sides. So I got angle A is equal to the inverse sine of 15 times sine of 33 over 10. And when I plug that into a calculator, I get about 54.78 degrees. So that's my first measurement here for my big triangle. Now all I need to do for angle C here, I know that this is about 54.78. So I'm going to take 180 and subtract the 2 angles that I know to find my third angle. So 180 minus 33 minus 54.78. And again, because I rounded A, then this angle C is also rounded. So just know that I get 92.22. And so just the way I'm going to write this here is like, I'm going to call this my first triangle, right? So measurement of angle A1 is equal to about 54.78. Measurement of angle C, is equal to about 92.22 degrees. So those are my two missing angles. My missing side length, I'm going to go ahead and use the law of sines again to find the missing side length. And I'll go ahead and set this up as my side length of C 1 over sine of 92.22 equals 10 over sine of 33. Multiply sine of 92.22 to both sides. Plug that into a calculator and round, and I get my side length of C as approximately 18.35 units. So those are my three missing pieces for the first possible triangle. I'm going to repeat that process here now for the second triangle, kind of, because one of the tools that I know, one of the tricks that I know is that angle A1 and angle A2 are supplementary, meaning I can subtract them from 180 to get our other angle A. So again, to make life a little bit easier here, I'm going to go ahead and the measure of angle A2 equals 180 minus 54.78. So my measurement of angle A2, which again, this is A2, is equal to approximately 125.22. Now I'm going to use that to help finish out this other triangle here. So measurement of angle C2 is going to be equal to 180 minus 33 minus 125.22. And we notice we're going to get a really small angle here of measurement of angle C2 is approximately 21.78 degrees. Again, smaller, which makes sense because, again, if we look back at these two triangles, C1 was kind of larger, C2 was much smaller. So that kind of makes sense. And the last thing I'm going to do is I'm going to use the law of sines to find my final side length here. So C2 over sine of 21.78 equals 10 over sine of 33. C2 equals 10 times sine of 21.78 over sine of 33. And that gives me an approximate value of 6.881. So C2 is approximately 6.81. So a lot to do on this problem, but we get all 6 of the values here that I'm looking for, right, for 2 different possible triangles. I get the missing 2 angle measures and then the missing side length after I prove that there are 2 possible triangles.